Subunit 4.3, Concept of Operations, Part 2. So I'll give you another example to kind of go from very large-scale human spaceflight down to smaller-scale robotic spacecraft and Earth-orbiting spacecraft, the Joint Polar Satellite System, JPSS, which is a current effort underway with NASA and NOAA working together to build a polar orbiting satellite that can do weather monitoring from low Earth orbit. And so it's a low Earth orbit, high inclination, polar orbiting satellite. It's collecting weather data from low Earth orbit. And if you ever hear about at NOAA, they have satellites in geostationary orbit as well, very high up. Those are the ones that you see on the nightly news that take pictures of the east coast of the US or the west coast. There are two of them, one on either side of the country. Those satellites take a picture over and over again that encompasses the country, and you can see weather patterns moving up the coast and all. These satellites that we're talking about here are in low Earth orbit. They're much closer to the Earth. Their cameras are able to get much higher fidelity information about the weather, but because they're in much lower orbit, but they're not covering the same spot continuously. They're constantly moving around the Earth as the Earth turns, and so they're taking pictures of different weather patterns at different spots at any given time. Their pictures are much more close in. Now, how do you get that data to the ground? And so I worked with this team early on as we were doing the concept of operations, and our big problem was, okay, you have this satellite, you have this very important weather data, and when it comes to weather prediction, the quicker you get the data down of the current weather situation, get it to the people who are doing weather forecasting, the better the forecast can be. And so now you've got this satellite traversing the world, North Pole to South Pole, as the Earth turns underneath. How do you get the data down to the ground quickly? If you fly over top of an antenna and try to dump data from a satellite in Earth orbit, you have about 15 minutes to dump that data from Earth orbit down to the surface. And so if you're doing that, you have to have a lot of these antennas spread out around the world so that as you're flying and collecting data, you could be dumping data every 10 or 15 minutes. And so in the Joint Polar Satellite System program, we ended up with a configuration of 15 to 20 small antennas spread out all over the world that would be able to collect data as this thing would fly over it. And so that was a very complex concept of operations. You had a lot of data distributed now as it's being collected around the world that has to be funneled all the way back to the National Weather Service or whoever else is going to get it. And so that became very complicated, not for the spacecraft, but for the ground segment. So when you develop space systems, you always have to keep in mind that these are integrated systems. Not only is there a space segment, there's a complicated ground segment. So the concept of operations has to include both to make sure that you're taking them into consideration. So I'll end with the most complex example we have here, and that's the human spaceflight mission to Mars. So NASA has for many years been looking at how to take people to Mars safely and bring them back. Many studies have been done, and this represents a concept for one of those studies that was looked at for taking a crew to Mars. They would stay on the surface, you see on the top of the chart, for over a year, and then they would come back to Earth. And so here again, you're seeing an architecture because you're seeing vehicles that are being developed as part of the system to make it work. But the concept of operations is more the discussion of how do those vehicles work together to perform the mission. So you can kind of use the same picture here to kind of walk through from end to end. On the left-hand side, you see the launches. There's a number of launches. The 2X on the bottom means there are two of these very large vehicles launching to bring cargo into orbit. There's another vehicle that's launching to bring the crew into orbit. There are many launches required to get all the equipment into Earth orbit to put this vehicle together to shoot it off to Mars. It's going to be a very complex mission. A lot of pieces have to come together. So this concept of operations kind of walks through the transfer of the cargo and crew off to Mars, the operations they will do on the surface of Mars, and then their return trip on the other side of the page. And so, again, this is going to really help the designers look at requirements and look at issues, right? If I'm coming at this new and I look at this design, I'm going to notice right away that there are a lot of vehicles required to launch off the surface of the Earth in a small amount of time to get all this cargo on orbit, to get the cargo and crew off to Mars. So maybe I'm going to go back and look at, geez, do I need that much equipment? Is there a way to take less equipment? Maybe there are different designs for rockets that need less fuel. Is there something I can do to reduce the number of launches that are needed to make this concept play out? So again, you'll see these as visual representations that look at both an architecture, a set of systems, but also a descriptive section in this will include what is my concept of operations at every phase? How will I operate that craft? And so that's what each mission we do at NASA has a concept, and we mature that through the design phases, usually starting in phase A. Now let's recap the objectives covered in this lecture. The first step in understanding a mission is to define a scope for that mission. It includes defining needs, goals, objectives, identifying stakeholders, developing an operations concept, understanding constraints. And it's by doing a thorough scoping effort, it leads to an organized and informed mission and system set of requirements that you can go off and develop from. And a concept of operations is a description of how the system will be operated during the mission phases in order to meet the stakeholder expectations. Congratulations, you made it to the end of Unit 4. Answer the last discussion question of the forum, after which you can move on to the Unit 4 quiz. Remember that this will count for 10% of your final grade, so study hard and good luck. After you take the quiz, continue working on the Mars Sample Return Mission Project.